I want to tell you about what this build is about, but there's some framing to do for the build first. And the framing is that all making involves holding on to stuff while you do other stuff to it. Sometimes you hold on to stuff with gravity. Sometimes you hold on to it with vices. Sometimes you screw it down, clamp it down. Work holding is what this is all about today. With the lathe, there are mechanical work holders like this, a 6-jaw chuck. I have 4-jaw, 3-jaw, all sorts of, that's 3J. Anyway, I have lots of different work holding options when it comes to the lathe. And one of the ones I like the most are the collets. Now, these are 2J collets. These are 5C collets. These are, over here, are ER collets. There's like as many collets as there are ideas about how to hold on to stuff. But today we're talking about 5C collets because they are the most common collet. And they follow the same form factor as many collets. I can't say all because I'm just not sure that I know all. So I'm just going to say many, in that it's got, you can see that it is a tube with a hole in it, and that there are 3 slits in it. And those slits allow, well, one, they allow it to be a really, really bad tuning fork. But 2, what they do is they allow movement of these 3 jaws in towards the center. And when you put a screw thread on the back of this and you pull on it, it pulls into a taper like this, and it closes those up and holds stuff. Now, I first learned about a 5C collet in Jamie Heinemann's shop when I was a young buck. And I remember it was excellent for repeat grabbing. Actually, yes. So one of the things that mechanical vices like this do is they grab the work really well, but in the really well department, they also mar it really well. And when you want to hold on to stuff tightly, but you don't want to harm it, collets are your jam. And there are different collets for different things, and there are high end and low end, et cetera, et cetera, et cetera. Why am I telling you all this? Because when I was working on the racks for my vault, I was holding on to my square 8mm racks with a square. I was holding on to my racks with a square 8mm 5C holder. Oh, that's the other thing about 5C holders. You can get them in squares of different types, both imperial and metric, and you can get them in hexes. Yeah, they even make emergency collets. They make expanding collets so you can hold on to the inside of stuff. 5C is a really robust system. But here I was working on the racks with these, and within the confines of the lathe, I needed to do the same operation to each. Am I getting too far into the weeds here? When you pull on the threads of a collet to put it in. All right, let's try this. This is my 5C collet holder for the lathe. Right now, it operates like this. You put a collet in here, and buried in the mechanics are screw threads that receive this. And when you put a chuck key in here and you turn it, it slowly pulls this down to clamp on your work. Great. With that established, I was putting racks into a square holder, and I wanted them all to go back to the same location so I could do the same operation on each one, and it would be the same every time. I.e., I wanted to take 12 similar pieces that were the same length, put them each one at a time into this, affect it with the lathe tools, and pull them out and have them all be identical. But there's a problem with this kind of chuck with that, which is if you really wanted to be exacting, you'd have to count exactly how many rotations on your chuck key you were doing. And even then, you might not be exactly right. So how do you get repeatability with a collet? Well, one way is you have a collet stop, which I have for the back of my collet, but that's not the way that I'm talking about today. The other way to get, and there are collet systems that have great repeatability specifically to address this kind of issue. But the one that I am about to do, as you might have surmised from the title, is to use a collet locker. That's what this is. This is a lever tool for, how does this work? Okay, here's the basic gist of it. I've established that the collet holds onto work by being pulled into a taper so that these things squeeze on the work. I have also established that if you want to squeeze different objects to the exact same degree, so you have, 1,000th of an inch accuracy and repeatability in the actions you're going to do inside a collet, this kind of collet chuck is not the best, because you'll have to count the number of rotations. You have to catch the same thread every time. It didn't work for me, and the 2 times I've tried to get repeatability out of this thing, this is like great for a one-off, and it's a cheap Chinesium chuck. It was like $150. There's a few different YouTube channels that have covered how very reasonable this piece of equipment is, but I need repeatability out of it. So I bought a Hardinge, is it a Hardinge? Happage, Royal Prods. I bought a collet closer that is fit for it's closely fit for my lathe. I'm gonna have to do some final modifications for it. And all it does is exploit an over center little catchment to basically, you're able to dial the collet closer in so that it clamps your work exactly how you want. Then you affect your thing and you move one lever to lock it, and you just push that lever back in the other direction to unlock it. It'll be really clear when I'm done. But what this is about to be is a retrofit. Luckily, the key interface between the collet locker and the lathe is this ring. And I was lucky in making sure, I made sure that the interior of this collet closer actually engages with a series of dogs. Dogs are what they call it when gear teeth like this align. Anyway, they're called dogs. There are 3 dogs in here that engage with the ridges on the outside of this ring, which is the back of my spindle on the lathe. And the collet locker is about engaging and disengaging that. So you disengage it to pull your work out, you engage it, clamps the collet, holds onto it. That's the theory. And I've been dying to put that theory into practice in this cave for a long time. And we're just about to do it. Now, because this 5C collet chuck has internal threads, I'm gonna have to take those out so that this will end up being just a fascia, just a front end is what it's gonna be. But that's cool, I'm fine with that. That still works for me. So, first things first, I want to take this thing apart and I want to figure out what mods I need to do to it. We will dial you in later, but right now. Did it. You don't need that thrust bearing anymore. This is not surprising, but yeah, this is just a little too tight for my collets. I'm just going to double check the other one. Oh, man, little tiny one. It turns out I do need to drill this out to fit the tube that is going to pull on my collet. So I am actually going to drill this out using this on the lathe. It should be a fairly simple operation and nice and slow. Respectable. One of the things I love most about the annular cutters here is how quiet they are and how slow. So we can do it like that. Really slow. So in addition, I also turned a couple of plugs because these pinions that turned the scroll that secured this down left two big holes in here. So I am plugging them with these two aluminum plugs. You'll see when I have them all in. We're gonna get this on the lathe, and then we're gonna get actually, we got to figure out if the lengths all work, or if I'm gonna have to modify this tube with another tube or something. So I've hit a snag. I knew this was going to be a snag. Right now, this is turning 3 thou out of true. There's 3 thousandths of run out. That is a very fixable amount. I can likely just machine a little bit of relief in the base and then loosen the 3 hex bolts that hold it on and give it some little tappy tap and bring it right in. But these collet lockers are all made for specific machines, and this one is 5 inches, 5.5, give or take, a little too short for my lathe, which means I need to order a piece of 1 3/8 OD steel tubing, and then I'm actually going to literally cut this probably right about here and make a insert sleeve on 2 halves that fits together and braze it all together. That should work. I'm going to get on ordering that piece of steel. I'm going to wash my hands. In the meantime, for most of its life, this back part of my lathe has been completely obscured by shelving because I've never had a collet locker. Now that I do, I need to be able to access this area. So that's the next thing I'm going to do. Yeah. I got the end cap of my lathe off. It turned out that the engagement cap for my locker is just a pressure fit, but it just like basically rusted onto the end. I used a 2-prong method. Hey, stay there. I used this stuff, Kano Aerocroil. I don't love the way it smells. I love the way it works. Put a little bit of that. It's a penetrant. Again, it smells terrible, but boy, does it get into stuff. Then I applied some map gas to the outside for a while. That would expand this, and Yeah, in this shop, we are always learning about how much things expand when you heat them. And that was the magic bullet in getting that out. This is a giant cast aluminum door that was the outside door to the left side of my lathe. Now, the locker needs to mount here to this 11-degree angle. Is that 11? Yeah, 11-degree angle. There are mechanical relationships between the pieces of the collet locker that are incredibly fine. So you cannot design in the proper tolerance. You need to design the ability to adjust to the proper tolerance. And so the main arm of at the other end of the locker arm is like a turnbuckle and allows you minute, fine adjustment of the relationships between. When you have an over-center rig that's doing something like this, right, like a suitcase latch, your persuasions can be quite precise. Anyway, so I need to make a nice solid base on this cast aluminum door. I'm going to clear my workbench and set it up there and start to make some drawings and figure out how much room, width, depth I have to work with and come up with a plan. I just need basically a little clevis sticking out of this thing. A clevis is a when two things go together, boop, and a pin goes between them, that's like a little clevis hinge. I think that's what a clevis is called. All right, I've successfully mounted this into the vise. This is great. I wonder if I can, let's see if I can get all the way to where I want to get to. This lathe was restored at one point. I can tell because whoever restored it was very indiscriminate with their spray painting. However, it did a nice job. I mean, this is the original handle of the original door. So I don't think that the original door was clear acrylic. So I'm going to, yeah, see that? That's what I'm going to do. Awesome. Just what I was hoping would happen. Do 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 do. Do 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 do. When you're a machinist, you are regularly creeping up on increments that are important. You are not trying to just get to them in one step. You're getting close and then double checking and getting even closer and then double checking and then getting even closer. But when you get to know your machines and you know your tolerances, that was me making one cut just to kind of lower it by a bit, seeing how much I had left, adding that into my DRO, slicing it off and being within 1/1000 or 25 microns of my goal. All right, so now I actually need to clean up this piece and this piece, get this back on, which might mean that I need to just hone the inside a little bit and then get it back on the back of the spindle. So let's separate those out. All right, I think we're ready to put this mostly back together. I know, I'm not doing a huge clean out here. I don't need to. This is fine. Fine, it's fine. That feels much better. Everything's in its place. So now I got to make some attachments for this to the locker. All right, so here's how these pieces work. What I need between the locker clevis and the clevis mounted on the lathe is an adjustable turnbuckle. So that's what this is. These are the two pivots. This one's on the lathe, this one's on the locker, and these two holes will get threaded with a 1/2 inch 13, which means with every turn, I'll be able to adjust the distance between these two things. Whoop, 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 whoop. Yeah. That is where we have to leave this one, because I need that 1 3/8 outer pipe to extend this puppy. And until I can, there's nothing else I could do. But very pleased am I with the rejiggered door for the 2 change gears that this lathe actually has. Here is my nice clevis for operation of the locker. I gotta tighten this up because it'll rattle. So this might be where this video ends, because I am lacking the last piece of pipe to do the extension on the main tube for the locker. That pipe's not going to show up for another 1.5 weeks. Well, that maybe it's part of the same video. Who knows? You know, I don't. If this is the end of the video, thank you. See you next time. If it's not, see you in a minute. When last we left our intrepid hero, he was working on extending a locker. This is a locking mechanism for using a collet system with my big engine lathe, and getting very repeatable results out of said engine lathe. The locker I bought is for one that I think is about 5 inches shorter between the end of the spindle and its nose. So I want to extend it. And this is an 1 3/8 OD pipe, thick wall. I found more of the same. I bought it in a 72-inch length. It was the only one available at the time. That's fine. I will always use pipe. There's always room for more pipe in the shop. So this is a tricky one. I soaked this in rustabator. I soaked this in a rust remover overnight and got perfect operation out of it. So very happy with that. I was thinking about rebuilding this entire shaft from scratch. All right. Rebuilding this shaft from scratch is non-trivial. There's threading, internal threading here. There's external threading here. All sorts of stuff going on. But it's doable. But do I want to do it? I just spent some time soaking this in rust remover and putting some anti-seize croil here that releases old metal. I tried removing this. It's very hard to remove. I did not succeed in any way. So I'd rather not try and remove this. But if I completely F this whole buildup, I will then cut this, pull this out, and remake the entire thing from scratch. I have enough of this stuff to do both. I'm only going to put in like a 5-inch extension or rebuild this entire bar. One of those two things. First up, though, I need to make some measurements. This is, I've been wanting to do this for a long time, and I'll be honest with you. Extending this shaft is a mechanically simple operation, and I'm nervous about getting it wrong. There's already a splice in here, and I have tried some heat that did not seem to help, so I'm going to ignore this splice. I know this is absolute concentricity in terms of expanding this is really important. That means that like it's really vital that I get it nice and round. So it means that it may be that when I finally do the assembly of this, that I push the pieces together, make them super clean, do a heat press fit with some Loctite, like do the whole business. Shbusiness. What's shbusiness? It's not personal, it's business. I can't remember what I was talking about. So I've cleaned up the shaft. I need to extend it by about 5 inches. I'm going to cut it right here. This is where it was joined before. That way I can see what their tolerance was for the thickness. They split it probably across both halves, but I'm going to need, once I split this, to actually, it's going to be a whole thing. And it's got to turn real true. So I'm going to work really hard at that part. It turns really true right now. It's a lovely piece. I would cut this on the lathe, but I don't like the amount of leverage that can do. This pipe is really important that I not damage it. So funnily enough, I'm going to cut it on the rough bandsaw here and then clean it up on the lathe. Once I have both ends cleaned up and bored out to the exact same degree, then I will pull the chuck off there, figure out the exact length that I need this thing to be, and machine the spacer part in between. So here we go. It's nerve-wracking to cut this. New plan. New plan. There's a new plan. There's a new plan in town. So the new plan is I cut the piece off, and weirdly, I was not able to separate these two at all, but the moment I cut them, I was. And so this has a threaded out here at the end. That's what's happening here. So I am going to remake this piece and not F with that bit at all. I just need to do some single point threading. So this is just going to be a single point threading day. right, now first things first is to clean up both ends of this. Yeah. Right. I was going to be dramatic. This is the moment of truth. This is my new locking bar. I have grafted an extension onto here. Now, I will tell you that the extension tube I bought is not as thick as the original tube it replaced. That didn't affect me being able to get it to turn on a nice center, but it does change the strength characteristics. I don't think that's going to be an issue. I've locked these two shafts together with Loctite and 3 pins, which I then turned. I can undo this if I need to. But I'm hoping this will actually work. And so now and the moment I finished this, it turned out that this shaft was too big by 10 thousandths to the hole here in the side of my lathe. So I'm going to true up the locking ring on the end of my spindle, and then we're going to try installing this for the very first time. Yeah, I'm very excited. All right. 1/2-inch drill bit. I've got a 1/2-inch collet in here. So this spins free until I lock this, and then it's locked. And then when I turn it on, yeah, I see that moves a lot. That's not my biggest issue. Let's see how bad it is. I don't like that. At any rate, functionally it's working. Just tuning wise, it's a little bit out. So let me muck around with this. See what I can achieve. Here and there. Let's see. It's done for now. Remember how at the very beginning of this I said I think I might have to remake the entire tube? I think that's what I'm going to do. I think I'm going to remake that entire tube. And I'm going to get this correct thick wall stuff. And yeah, I now know the exact measurements of the tube. I've got the proper operation here working. My issue is, and this is maybe why I got a good deal on this, is that the shaft seems bent after it's coming out of there. And I can address that by making a completely brand new shaft. It looks like this thing got a big ding somewhere in its lifespan that can't quite see when I look down the middle of it. For those of you saying that I should be like Joe Pye and tune my locker ring, I did. I actually tuned it to within half a thou. Yeah, 12 microns or so. And that's not the issue. I'm getting a nice straight turn coming out of the back, but it's bending after it comes out of the back. So I can use it to do the build I need to do with the safe, which I can make my stop and I can cut my pieces for the safe. Yes. And in the future, I am going to rebuild this. In the future, I'm going to rebuild this thing so that I can, because this is great. What this does is it pulls the, I almost couldn't have explained it until I'm at the very, very end of this. But basically, this collet here, the three lobes that make it up, they tighten by being pulled from here back into there. And that's what I can do with this lever now. I can tighten and still start it up. Yeah. The first time I used one of these, this is so funny how, hold on. The first time I used one of these, it's so funny how instruction happens. Jamie was like, oh, if you're going to repeat that part, you probably want to use a locker so you can repeat. And that's all he said. And I understood what concept he was referring to. And then there was a bin of parts called the locker or the collet locker. And I pulled them out and I looked at it and I sort of figured it out. Like I said, this is operational. So I'm going to do the safe thing. I'm going to do the safe thing. Don't you fall. I'm going to do the vault. And then at the same time, I'm going to go on eBay tonight and look up 1 3/8 thick wall steel. Hey guys. How you doing? So we are wrapping up the lathe collet chuck video here. It's been a journey. I will admit to you, it has been a journey. So, yeah, this collet locker was not built for this lathe. It was 6 inches short, so I rebuilt the threaded section that interfaced with the collets out here and the tightener here. I'm still getting a tiny bit of a rattle. That's like a classic, like, and I can't figure out why it's not turning on center. I pulled the whole thing out, ran it between centers. It mics in nice and tight. But it's no longer bagonking on me. It is just, which is fine. That's fine. And I can now pull pieces out and put them back in. Oh, and here we go. That is like such a sweet luxury. I can't wait till I've got like a production level of stuff to do to churn them out. And I can use the locker to like bang, bang, bang. Yes. And the last thing I want to say is, like I said at the beginning of this video, or maybe I haven't even said it at the beginning of this video, this 5C collet chuck was like a sub $175 eBay purchase. There's lots of machinists talking about this chuck online. Lots. I mean, I found at least 3 different makers talking about this chuck, and it's semi-accuracy. It was a scroll chuck, so it had a chuck key here, a square drive here, and a scroll to tighten the chuck. But since I've replaced that with the locker, I was able to pull the entire scroll out completely. Hang on. Where is it? It's over here. There it is. That's one of the square drives, and it's got these gear teeth that interface with the scroll that is basically just a threaded insert, and that bottom thread grabs the collet chuck. The collet. The chuck's collet. I have now made registration marks on the assembly of this so that I put it back in the same position. I was able... So lathe chucks are often combined of a backing plate and a chuck. And this backing plate was one that I had and modified for this chuck. It was super close, and the chuck had about 3/1000 of run out. That's about the thickness of a sheet of paper that it's non-concentric. I was able to pull most of that non-concentricity out. I was able to get a 1 micron micrometer on here, and I got this round. This is now turning within 0.5 or 0.5 or 12 microns for those metrologically inclined. Thank you guys for joining me for the edition of this love. I have one more coda for the lathe. One more coda, which is, I read the machinist forums, and I'm a member of several. And, I read Practical Machinist and R Machinist and stuff like that. And there's this big divide between CNC machinists and manual machinists. Well, it feels like there's a divide. It feels like a lot more people know manual machining. And there's a lot of back and forth. And, the old engineers can get cranky. What I wanted to say, read the debate between manual versus CNC machining is that I don't think there's a debate. I think they are both very difficult skills to be great at. They are both skills that it is not too hard to be passable at. And therein, in that divide there lies like all of the learning. I will tell you that becoming a better manual machinist makes me terrified of CNC, because the idea that I'm going to get all the feeds and speeds right and not shatter my bits and destroy my work it beggars my imagination when I'm thinking about changing bits and all that stuff. And I recognize that a good CNC operator has built institutional knowledge of the metals that they work with in their shop and the tolerances that they need, etc. So that's a long way of saying I think that if I did CNC, it would make me a better manual machinist, and that my understanding of metal using the manual machines is excellent and sets me up nicely for CNC machining, because really it's about knowing the metal and it's about knowing how the metal is going to behave. So I think that all CNC machinists should cut some metal on a manual machine. And I also think, and I will do this, I promise, that all manual machinists should try some CNC. That's what that thing is for. I swear I'll get that up and running. All right. This is the second time I've shot this, because last time there was like a big Megillah in the frame that we didn't want to show you just yet because we're saving it for a little later in the year. All right. Bye. Cheers.